How can an airplane fly without knowing its true speed? Find out how this absurd and extremely dangerous scenario could have been avoided. In today's video, we'll explore Flight 134, where a minor oversight led to a near-death experience. On the night of July 18, 2018, a Malaysia Airlines Airbus A330-300, registered 9M-MTK, was being prepared for a regular public transport flight from Brisbane Airport, Queensland, to Kuala Lumpur, Malaysia, with call sign MH134. The preparation for the flight and the flight itself were conducted at night in clear weather with light winds. When the aircraft arrived at the gate after its flight to Brisbane, an engineer put covers on the 3 pitted probes to protect them from being blocked by wasp nests, which can be a problem at Brisbane Airport. However, the pitted covers were not taken off during the inspections, and other tasks were done during the turnaround. This near-death catastrophe during a Malaysia Airlines flight could have been avoided if the pilots and maintenance crew followed pre-flight checks properly. However, the flight crew began their pre-flight checks around 10:10 p.m., including reviewing the aircraft's technical log. At 11:11 p.m., preparations for departure began with the tow bar attached and the main passenger door closed. During takeoff at 11:31 p.m., the crew faced issues with unreliable airspeed and red speed flags on the primary flight displays. The first officer requested switching air data sources and conducted troubleshooting. The flight crew continued to struggle with airspeed readings, causing a pan-pan emergency call at 11:33:04 p.m. The crew received clearance to climb to 6,000 feet, but the tower controller didn't respond to the emergency call. As the plane climbed, the crew followed unreliable speed indication procedures but had difficulty with air data. After climbing to higher altitudes, they requested further climb to flight level 1502, which ATC approved. Approaching the landing, the crew informed ATC about their lack of airspeed information and received ground speed updates. At 12:31 a.m., the plane conducted an overweight landing on runway 01 at 152 knots. The main landing gear doors touched the runway during landing, causing minor damage. Thankfully, all members on board were safe and no injuries or fatalities were reported. After ground inspections, the plane was towed to the terminal, where passengers and crew disembarked safely. But what exactly was the cause of this peculiar series of events? Before we talk about the issue, it's important to know more about airplanes. The aircraft involved was an Airbus A330-323XZ, serial number 1388, registered as 9M-MTK. It was operated by Malaysia Airlines and belonged to the high-capacity jet sector. The A330-323 is designed to accommodate a higher number of passengers with a longer fuselage compared to other variants in the A330 family. The layout typically consisted of a dual-class seating arrangement, although it can be customized to include different cabin configurations. The aircraft we are talking about is one of 15 Airbus A330-300 aircraft operated by Malaysia Airlines. Furthermore, the Airbus A330 has fly-by-wire flight controls. The aircraft's flight control surfaces are electrically controlled and hydraulically actuated, and flight control computers process pilot and autopilot inputs to direct the control surfaces as required. There are 3 flight control primary computers and 2 flight control secondary computers. Now that you have a good idea about the aircraft, let's discuss the issue faced by Flight MH134. The support engineer put covers on the plane's pitted probes, the airspeed sensors to protect them from wasps at Brisbane Airport, a common occurrence at the Brisbane Airport. But the certifying engineer, responsible for the plane's safety, didn't know about the covers at first because of a communication mix-up with the support engineer. The flight crew, engineers, and dispatch coordinator had to do pre-departure checks to spot aircraft damage or unsafe conditions like pitted probe covers. However, these checks were skipped or not done properly for various reasons, such as poor communication and lack of attention. This issue also happened on other flights from the same operator, where some checks were missed or incomplete. The certifying engineer saw the covers early in the turnaround but later forgot about them, and there was ambiguity around the division of responsibilities about the final walk-around portion of the transit check. The support engineer who put on the pitted covers left to work on another plane and didn't return before the affected aircraft was dispatched. There was no system in place to make sure all tools and equipment were removed before a flight. The Australian Transport Safety Bureau, ATSB for short, found that the pidot covers used were not the type approved by the aircraft manufacturer. These covers had streamers that were not noticeable enough to be seen by ground crews during tasks like pushback, which increased the risk during turnarounds if other methods for their removal failed. One important thing that should be mentioned is that airplanes are very different from other vehicles such as cars. Exact airspeed is crucial for a safe and sound flight. Airspeed helps in safe takeoff and landing speeds. Airflow helps to generate lift beneath the wings of the airplane. Without the knowledge of airspeed, the airplane might simply stall during the flight. Now with this out of the way, let's take a deeper look at the incident. This near-death catastrophe could have been avoided very easily if the pilots and the maintenance crew had followed the pre-flight checklist. But why didn't they? Let's explore this. The flight crew arrived at the aircraft flight deck at around 22:10, shortly before refueling began, and commenced a series of pre-flight checks. As part of these checks, the flight crew was required to review the aircraft's technical log for outstanding defects. No defects relevant to the occurrence were recorded. As the pilot monitoring, PM for short, the captain was responsible for conducting the exterior walk-around inspection. The captain started the walk-around at 10:54 p.m. and briefly shone a flashlight on one of the left side pidot probes but did not check the right side of the nose. During an interview with the ATSB, the captain could not remember seeing pidot probe covers. The ATSB concluded that the captain's walk-around was missing many required checks due to the inspection path taken, use of the flashlight, and time spent on the walk-around, showing a lack of thoroughness. At 11:11 p.m., the tow bar was attached to the plane, the main passenger door was closed, and the air bridge was moved away. Menzies assigned a team of ground staff to handle the turnaround of 9M MTK. A lead staff member was in charge of all non-engineering ground tasks and was responsible for coordinating the dispatch. The lead staff member hadn't received specific training from the airline and didn't think they were qualified to handle the dispatch. So, just before the plane was set to leave, the lead staff member asked a ground handler from another team to take over the dispatch coordination. They asked, "Can you handle the headset?" And the new coordinator signaled thumbs up to confirm. A dispatch coordinator was supposed to do a final walk-around before departure. The leading hand said they usually checked the plane for visible damage right after it arrived and did a final walk-around as part of the dispatch duty. This included making sure baggage doors and hatches were secured and doing other last-minute checks. However, the leading hand didn't tell the dispatch coordinator that they hadn't done the final walk-around. The dispatch coordinator thought the plane was ready to go because the air bridge was retracted, the tug was connected, and the driver was in place. The dispatch coordinator assumed the leading hand had already done the walk-around and didn't ask about it. CCTV footage showed that neither of the Menzies staff members did the final walk-around. The dispatch coordinator put on the headset to talk to the cockpit at 11:15 p.m., and both staff members waited near the nose gear for pushback. After pushback and engine start, the flight crew requested clearance to taxi. At 11:24 p.m., the flight crew commenced taxiing for a full-length takeoff on runway 01. During the short duration of the taxi, they were mostly engaged in conversation that was not pertinent to the flight. This conversation ended about 3 minutes before the takeoff commenced. The plane carried 215 passengers and 14 crew members. It was a routine flight on a routine route, nothing special. But one small oversight during pre-flight check was going to make this flight every bit other than routine. The first officer was flying the plane, and the captain was monitoring the flight. Before takeoff, they calculated the plane's critical speeds. The decision speed, V1, the maximum speed for stopping a takeoff in case of emergency, was set at 153 knots. The rotation speed, VR, when lifting the nose for takeoff, was set at 160 knots. For takeoff, the airline's procedures required the captain to announce when the speed reached 100 knots, and the first officer would check the speed. The weather was clear with no wind. At 11:24 p.m., the crew began to taxi for takeoff on runway 01. At 11:31:38 p.m., the captain announced 100 knots as the aircraft's ground speed reached 100 knots. At 11:31:47 p.m., the first officer began lifting off, with the aircraft's ground speed recorded at 165 knots. The crew remembered noticing a problem with the airspeed during takeoff, seeing red speed flags on both primary flight displays. At the time of the takeoff, there was no clouds and surface winds were variable at 3 knots. Wind aloft varied up to about 10 knots from the north or north-northeast, providing a slight headwind on takeoff and landing. Due to the low winds in the area, ground speed was likely to have been very similar to airspeed, particularly up to 1,000 feet, so ground speed is provided as an approximation to airspeed throughout this report. The captain later recalled that the takeoff seemed to happen in a split second. According to the procedures, the captain was in charge of deciding whether to stop or continue the takeoff. Rejecting the takeoff between 100 knots and V1 is serious, and captains should usually be ready to continue. Only rare situations would lead to stopping the takeoff. The cockpit voice recorder did not record any discussion between the captain and the first officer about rejecting the takeoff. After takeoff, the primary flight displays showed a speed flag and sometimes very low airspeed. The standby instrument showed speeds near 30 knots during takeoff and below 60 knots for the rest of the flight. At around 300 feet, the first officer asked about switching to ADR-3 for their air data source. They switched to the first officer's side at 11:32:10 p.m. as the plane climbed past 600 feet. Around 700 feet, the first officer lowered the pitch and kept 9-degree nose up with maximum thrust. The plane was below the safe altitude of about 2,500 feet at night, but the crew didn't discuss flight safety. There were no ground hazards or other aircraft nearby. The first officer called for auto-thrust ECAM actions at 11:32:22 p.m. when they were passing 1,000 feet due to an alert about auto-thrust disengagement. The captain responded immediately, and they began the ECAM actions. At 1,500 feet, a master caution alert appeared with a chime and the message FCTL ALTN law due to invalid air data. The aircraft had entered alternate law after takeoff. The crew continued the ECAM actions but were interrupted at 11:32:45 p.m. by the tower controller asking them to contact departures. The captain requested and confirmed the departure frequency. The plane was passing 2,500 feet at this time. After takeoff, the primary flight displays showed a speed flag and sometimes very low airspeed. The standby instrument showed speeds near 30 knots during takeoff and below 60 knots for the rest of the flight. At 11:33:04 p.m., right after the captain repeated the frequency, the first officer suggested declaring a pan-pan emergency. The first officer then radioed the tower saying, "Pan-pan, pan-pan, pan-pan, Malaysian 134. We have unreliable airspeed and request to maintain runway track and climb to 6,000 feet initially." But the tower controller didn't remember hearing this call and didn't respond. ATC data showed the call was received on the tower frequency and there were no other transmissions around this time. The pan-pan call came about 40 seconds after a coordination phone call between the tower and departure controllers. About 28 seconds after the pan-pan call, another plane's crew asked for takeoff clearance, which the tower controller granted. Right after giving clearance, the tower controller got a call from the departures controller asking if the Malaysia Airlines plane could switch to the departure frequency. The tower controller said the switch had already been made and would check again. During this conversation, the crew of the departing plane asked if the controller heard the pan-pan call. The tower controller thought the transmission came from the phone line at the departures controller's terminal and didn't respond. The tower controller then asked the Malaysia Airlines crew to switch frequencies again, which the first officer confirmed. As the plane climbed through 3,800 feet, the first officer called for the unreliable speed indication procedure. Neither pilot remembered the procedure offhand, so the captain looked it up in the quick reference handbook. After switching to the departure frequency, the first officer made another pan-pan call at 11:34:21 p.m. when the plane was passing 5,800 feet, asking to climb to 10,000 feet and stay on the runway track. The departures controller acknowledged the pan-pan call and gave the clearances. The captain asked the first officer if the autopilot could be turned on, but the first officer said it couldn't. They didn't follow the after takeoff procedure. At around 11:35 p.m., when the plane was climbing through 7,000 feet, the crew started the unreliable speed indication procedure, adjusting pitch and thrust settings and checking the maximum permitted altitude for the flap setting. The thrust levers stayed in the maximum continuous thrust position, and the first officer kept the pitch between 9 and 12 degrees until the plane leveled off. As the plane neared 10,000 feet, the first officer requested a further climb to flight level, FL for short, 1502, which ATC approved. The crew continued the procedure, discussing how to level the plane. The FO told the captain to pause the procedure because they needed to focus on flying the plane. The departures controller asked the flight crew about their intentions, and they advised that they had no airspeed information. In response, the controller provided ground speed information and offered to provide regular ground speed updates, which the captain accepted. The controller advised the tower controller of the situation, and the tower controller performed many of the required alert phase actions, including preparing for fire services. At 11:53 p.m., the flight crew discussed available options for landing. They decided to conduct an overweight landing on runway 01 and began planning their approach and landing accordingly. ATC transferred the aircraft to the tower at 0031 when the aircraft was at 1,900 feet on approach. The departures controller advised the tower controller, who was the same as during the takeoff, that the flight crew requested ground speed information. At 0033, the flight crew conducted an overweight landing on runway 01 at 152 knots ground speed, touching down at about 390 meters from the threshold, near the point. The maximum recorded vertical acceleration on landing was 1.26 Gs, which the aircraft manufacturer reported was within the design load limits. The FO selected reverse thrust and stopped the aircraft about 1,600 meters short of the runway end. The aircraft could not be moved immediately due to the main landing gear doors, which do not close following a gravity extension, being in contact with the runway. The licensed aircraft engineer was called to the flight deck and, after the flight crew explained the instrumentation problem, recalled that pitot probe covers had been fitted and suspected that they may not have been removed. The engineer opened and leaned out of a side window and identified the presence of covers on the pitot probes. After the ground inspections established that the aircraft was safe to tow, it was towed to the terminal where the passengers and crew disembarked. Thankfully, there were no reported injuries. The main landing gear doors were slightly damaged when they touched the runway during landing. Normally, the doors stay clear of the ground when open, such as for maintenance. But during the overweight landing, the main landing gear struts compressed, causing the doors to hit the runway. The pitot probe streamers were damaged by airflow and left red marks on the fuselage skin where they rubbed during the flight. The term mud wasp refers to several wasp species, including mud dauber, keyhole, and potter wasps. These wasps get their name from their nests, which are primarily made of mud or sand and can be built in old nests from other species or small cavities in human-made objects. The wasps place captured spiders or insects inside the nests as food for their larvae. Mud wasps are common across Australia, particularly along the eastern coast, especially in tropical Queensland. At least 10 distinct species of mud wasps have been identified at Brisbane Airport. Historically, mud wasps have been known to build nests in aircraft pitot probes, entering through the forward-facing opening. Nesting and food material placed in the cavity blocks the probe, to the point where it may no longer provide accurate airspeed information. A partial blockage, such as that caused by the first addition of mud for a nest, may be enough to cause anomalous airspeed readings as airflow is disturbed. Brisbane Airport Corporation manages the risk mud wasps pose to aircraft as part of its broader wildlife hazard management program. The airport holds bi-monthly internal and quarterly external wildlife management meetings and provides educational materials for airport workers. To manage wasps, the airport uses both direct and indirect control methods, including removing nests, limiting nesting materials and food sources, and selectively eradicating wasps. Shortly after the occurrence, the ATSB issued a safety advisory notice advising all operators that conduct flights to Brisbane Airport to consider the use of pitot probe covers and, if covers are used, ensure that there are rigorous processes for confirming that covers are removed before flight. Furthermore, the ATSB issued a safety advisory notice urging all manufacturers and operators of larger air transport planes to think about the kinds of unreliable airspeed events that can happen, how the information is presented to flight crews, and the safest responses at different stages of takeoff in various situations. Aircraft alerting systems, flight crew procedures, and training should ensure that crews are aware of and know how to respond to unreliable airspeed during takeoff promptly. Moreover, Malaysia Airlines took several safety measures following the occurrence to address issues identified by the ATSB. The airline added procedures to place a placard in the flight deck as a visual alert for crews when pitot probe covers are installed. Changes were also made to engineering arrangements in Brisbane to reduce the chance of errors. The airline published a flight safety bulletin to remind crews to stay vigilant during walkarounds. In addition, they implemented numerous changes to their change and risk management processes. Airbus also made some crucial updates in their safety manual. They implemented additional flight crew training standards about unreliable airspeed on takeoff, including walkarounds, airspeed monitoring, systems knowledge, and non-technical skills. They added guidance to the flight crew techniques manual on the importance of airspeed monitoring on takeoff. Lastly, they commenced a review of airspeed indications in A330 and other aircraft types. Well, that will be it for today's video. Let us know in the comments below about any other aviation-related incident that you want to hear about. Don't forget to like and share this video. Subscribe to our channel so you won't miss any new videos. As always, see you in the next one.